This article describes the history of construction tools and methods, how things were built. See History of Architecture for the history of building types and styles, what things were built. See History of Structural Engineering for the history of building structures. People have constructed buildings and other structures since prehistory, including bridges, amphitheatres, dams, roads and canals. Building materials in present use have a long history, and some of the structures built thousands of years ago are regarded as remarkable. The history of construction overlaps that of structural engineering and many other fields. To understand why things were constructed the way they were in prehistory, we also need to rely on archaeology to record the form of the parts that survive and the tools used, and other branches of history and architecture to investigate how the builders lived and recorded their accomplishments. The history of building is marked by a number of trends. One is the increasing durability of the materials used. Early building materials were perishable, such as leaves, branches, and animal hides. Later, more durable natural materials such as clay, stone, and timber, and, finally, synthetic materials such as brick, concrete, metals, and plastics were used. Another is a quest for buildings of ever greater height and span. This was made possible by the development of stronger materials and by knowledge of how materials behave and how to exploit them to greater advantage. A third major trend involves the degree of control exercised over the interior environment of buildings. Increasingly precise regulation of air temperature, light and sound levels, humidity, odors, airspeed, and other factors that affect human comfort has been possible. Yet another trend is the change in energy available to the construction process, starting with human muscle power and developing toward the powerful machinery used today. Also, a trend toward more fire-safe materials. Chronological development. Neolithic construction. Neolithic, also known as the New Stone Age, was a time period roughly from 9000 BC to 5000 BC, named because it was the last period of the age before woodworking began. The tools available were made from natural materials including bone, antler, hide, stone, wood, grasses, animal fibers, and the use of water. These tools were used by people to cut, such as with the hand axe, chopper, adze, and kelp. Also to scrape, chop, such as with a flake tool, pound, pierce, roll, pull, lever, and carry. Building materials included bones such as mammoth ribs, hide, stone, metal, bark, bamboo, clay, lime, plaster, and more. For example, the first bridges made by humans were probably just wooden logs placed across a stream, and later timber trackways. In addition to living in caves and rock shelters, the first buildings were simple shelters, tents like the Inuits' teepee, and huts sometimes built as pit houses meant to suit the basic needs of protection from the elements, and sometimes as fortifications for safety, such as the crannock, built self-sufficiently by their inhabitants rather than by specialist builders, using locally available materials and traditional designs and methods which together are called vernacular architecture. The very simplest shelters, tents, leave no traces. Because of this, what little we can say about very early construction is mostly conjecture and based on what we know about the way nomadic hunter-gatherers and herdsmen in remote areas build shelters today. The absence of metal tools placed limitations on the materials that could be worked, but it was still possible to build quite elaborate stone structures with ingenuity using dry stone walling techniques such as its Scarabraean. Scotland, Europe's most complete Neolithic village. The first mud bricks are formed with the hands rather than wooden molds, belong to the late Neolithic period and were found in Jericho. One of the largest structures of this period was the Neolithic longhouse. In all cases of timber-framed and log structures in these very early cultures, only the very lowest parts of the walls and post holes are unearthed in archaeological excavations, making reconstruction of the upper parts of these buildings largely conjectural. Neolithic architecture ranges from the tent to the megalith and rock-cut architecture, which are frequently temples, tombs, and dwellings. The most remarkable Neolithic structure in Western Europe is the iconic megalith known as Stonehenge, regarded by some archaeologists as displaying methods of timber construction such as at Woodhenge translated into stone, a process known as petrification. The now ruinous remains are of post and lintel construction and include massive sandstone lintels which were located on supporting uprights by means of mortise and tenon joints, the lintels themselves being end-jointed by the use of tongue and groove joints. There is also evidence of prior fabrication of the stonework. The symmetrical geometric arrays of stone clearly indicate that the builders of Stonehenge had mastered sophisticated surveying methods. Neolithic villages large enough to have rural and urban features are called proto-cities to distinguish them from cities beginning with Eridu. Gallery of Neolithic tools. Copper Age and Bronze Age construction. The Copper Age is the early part of the Bronze Age. Bronze is made when tin is added to copper and brass is copper with zinc. Copper came into use before 5000 BC and bronze around 3100 BC. Although the times vary by region, copper and bronze were used for the same types of tools as stone, such as axes and chisels, but the new, less brittle, more durable material cut better. Bronze was cast into desired shapes and if damaged could be recast. A new tool developed in the Copper Age is the saw. Other uses of copper and bronze were to harden the cutting edge of tools, such as the Egyptians using copper and bronze points for working soft stone, including quarrying blocks and making rock-cut architecture. During the Bronze Age the corbelled arch came into use, such as for beehive tombs. The wheel came into use but was not common until much later. Heavy loads were moved on boats, sledges or on rollers. The Egyptians began building stone temples with the post and lintel construction method, and the Greeks and Romans followed this style. Iron Age construction. The Iron Age is a cultural period from roughly 1200 BC to 50 BC with the widespread use of iron for tools and weapons. Iron is not much harder than bronze, but by adding carbon iron becomes steel, which was being produced after about 300 BC. Steel can be hardened and tempered, producing a sharp, durable cutting edge. A new woodworking tool allowed by the use of steel is the handplane. Ancient Mesopotamia. The earliest large-scale buildings for which evidence survives have been found in ancient Mesopotamia. The smaller dwellings only survive in traces of foundations, but the later civilizations built very sizable structures in the forms of palaces, temples and ziggurats, and took particular care to build them out of materials that last, which has ensured that very considerable parts have remained intact. Major technical achievement is evidenced by the construction of great cities such as Uruk and Ur. The Ziggurat of Ur is an outstanding building of the period, despite major reconstruction work. Another fine example is the Ziggurat at Choasanbul in modern Iran. Cities created demands for new technologies such as drains for animal and human sewage and paved streets. Archaeological evidence has shown the existence of pitched brick vaults such as at Tel al-Rima in what is now Iraq. Materials. The chief building material was the mud brick, formed in wooden molds similar to those used to make adobe bricks. Bricks varied widely in size and format, from small bricks that could be lifted in one hand to ones as big as large paving slabs. Rectangular and square bricks were both common. They were laid in virtually every bonding pattern imaginable and used with considerable sophistication. Drawings survive on clay tablets from later periods showing that buildings were set out on brick modules. By 3500 BC, fired bricks came into use, and surviving records show a very complex division of labor into separate tasks and trades. Fired bricks and stone were used for pavement. Life in general was governed by complex ritual, and this extended to rituals for setting out buildings and molding the first bricks. Contrary to popular belief, the arch was not invented by the Romans, but was used in these civilizations. The later Mesopotamian civilizations, particularly Babylon and thence USA, developed glazed brickwork to a very high degree, decorating the interiors and exteriors of the buildings with glazed brick reliefs, examples of which survive in the Tehran Archaeological Museum, the Louvre Museum in Paris, and the Pergamon Museum in Berlin. Ancient Egypt. As opposed to the cultures of ancient Mesopotamia, which built in brick, the pharaohs of Egypt built huge structures in stone. The arid climate has preserved much of the ancient buildings. Materials. Adobe construction was used for ancillary buildings and normal houses in ancient times, and is still commonly used in rural Egypt. The hot, dry climate was ideal for mud brick, which tends to wash away in the rain. The Ramesseum in Thebes, Egypt, provides one of the finest examples of mud brick construction. Extensive storehouses with mud brick vaults also survive, all constructed with sloping courses to avoid the need for formwork. The grandest buildings were constructed in stone, often from massive masonry blocks. The techniques used to move massive blocks used in pyramids and temples have been subject to extensive debate. Some authors have suggested that the larger may not be cut stone but fabricated with concrete technology. Although the Egyptians achieved extraordinary feats of engineering, they appear to have done so with relatively primitive technology. As far as is known, they did not use wheels or pulleys. They transported massive stones over great distances using rollers, ropes and sledges hauled by large numbers of workers. The ancient Egyptians are credited with inventing the ramp, lever, lathe, oven, ship, paper, irrigation system, window awning, door glass, a form of plaster of Paris, the bath, lock, shadoof, weaving of standardized measurement system, geometry, silo, a method of drilling stone, saw, steam power, proportional scale drawings, enameling, veneer, plywood, rope truss, and more. There are no surviving Egyptian manuals, so there has been considerable speculation on how stones were lifted to great heights and obelisks erected. Most theories center on the use of ramps. Imhotep, who lived circa 2650–2600 BC, is credited with being the first recorded architect and engineer. Achievements. The pyramids are chiefly impressive for their enormous size and the staggering manpower that must have been employed in their construction. The largest is the Great Pyramid of Giza, which remained the tallest structure in the world for 3,800 years. The engineering problems involved were chiefly to do with the transport of blocks, sometimes over long distances, the movement into location and exact alignment. It is now generally agreed that the skilled building workers were respected and well treated, but undoubtedly very large numbers of laborers were necessary to provide the brute force. The methods used in the construction of the pyramids have been the subject of considerable research and discussion. Ancient Greece. The ancient Greeks, like the Egyptians and the Mesopotamians, tended to build most of the common buildings out of mud brick, leaving no record behind them. However, very many structures do survive, some of which are in a very good state of repair, although some have been partly reconstructed or re-erected in the modern era. The most dramatic are the Greek temples. The Greeks made many advances in technology, including plumbing, the spiral staircase, central heating, urban planning, the water wheel, the crane, and more. The oldest construction drawing is in the Temple of Apollo at Dodoma. An unfinished stone wall was etched with the profiles of columns and moldings, and the wall was never finished, so the drawing was not erased. A rare glimpse into the history of working construction drawings. No timber structures survive, so our knowledge of how these were put together is limited. The spans are, in the main, limited and suggest very simple beam and post structures spanning stone walls. For the longer spans it is uncertain if the Greeks or Romans invented the truss, but the Romans certainly used timber roof trusses. Before 650 BCE, the now famous ancient Greek temples were built of wood, but after this date began to be built of stone. The process of a timber structure being repeated in stone is called petrification or petrified carpentry. Fired clay was mainly restricted to roofing tiles and associated decorations, but these were quite elaborate. The roof tiles allow a low roof pitch characteristic of ancient Greek architecture. Fired bricks began to be employed with lime mortar. Very prominent buildings were roofed in stone tiles, which mimicked the form of the terracotta counterparts, while later cultures tended to construct the stone buildings with thin skins of finished stones over rubble cores. The Greeks tended to build out of large cut blocks, joined with metal cramps. This was a slow, expensive and laborious process which limited the number of buildings that could be constructed. The metal cramps often failed through corrosion. Building structures mostly used a simple beam and column system without vaults or arches, which placed strict limits on the spans that could achieve. However, the Greeks did construct some groin vaults, arch bridges and, with the Egyptians, the first high-rise, the Lighthouse of Alexandria, one of the 7 wonders of the ancient world. Greek mathematics was technically advanced, and we know for certain that they employed and understood the principles of pulleys, which would have enabled them to build jibs and cranes to lift heavy stonework to the upper parts of buildings. The surveying skills were exceptional, enabling them to set out the incredibly exact optical corrections of buildings like the Parthenon, although the methods used remain a mystery. Simpler decoration, such as fluting on columns, was simply left until the drums of the columns were cut in place. The ancient Greeks never developed the strong mortars which became an important feature of Roman construction. Roman Empire, in striking contrast to previous cultures, an enormous amount is known about Roman building construction. A very large amount survives, including complete intact buildings like the Pantheon, Roman very well preserved ruins at Pompeii and Herculaneum. We also have the first surviving treatise on architecture by Vitruvius, which includes extensive passages on construction techniques. Materials. The great Roman development in building materials was the use of hydraulic lime mortar called Roman cement. Previous cultures had used lime mortars, but by adding volcanic ash called pozzolana, the mortar would harden under water. This provided them with a strong material for bulk walling. They used brick as stone to build the outer skins of the wall and then filled the cavity with massive amounts of concrete, effectively using the brickwork as permanent shuttering. Later they used wooden shuttering, which was removed for the concrete to cure. An example of a temple made of Roman concrete in the 1st century BC is the Temple of Vesta in Tivoli, Italy. The concrete was made of nothing more than rubble and mortar. It was cheap and very easy to produce and required relatively unskilled labor to use, enabling the Romans to build on an unprecedented scale. They not only used it for walls but also to form arches, barrel vaults and domes, which they built over huge spans. The Romans developed systems of hollow pots for making the domes and sophisticated heating and ventilation systems for the thermal baths. The Romans substituted bronze for wood in the roof truss of the Pantheon's portico, which was commissioned between 27 BC and 14 AD. The bronze trusses were unique, but in 1625 Pope Urban VIII had the trusses replaced with wood and melted the bronze down for other uses. The Romans also made bronze roof tiles. Lead was used for roof covering material and water supply and waste pipes. The Latin name for lead is plumbum, thus plumbing. Romans also made use of glass in construction, with colored glass in mosaics and clear glass for windows. Glass came to be fairly commonly used in windows of public buildings. Central heating in the form of a hypocaust, a raised floor heated by the exhaust of a wood or coal fire. Organization of labor. The Romans had trade guilds. Most construction was done by slaves or freedmen. The use of slave labor undoubtedly cut costs and was one of the reasons for the scale of some of the structures. The Romans placed considerable emphasis in building the buildings extremely fast, usually within 2 years. For very large structures, the only way this could be achieved was by the application of vast numbers of workers to the task. Technology. The invention of the water wheel, sawmill, arch, and were by the Romans. The Romans also began using glass for architectural purposes after about 100 CE and used double glazing as insulated glazing. Roman roads included corduroy roads and paved roads, sometimes supported on raft-to-pile foundations and bridges. Vitruvius gives details of many Roman machines. The Romans developed sophisticated timber cranes, allowing them to lift considerable weights to great heights. The upper limit of lifting appears to have been about 100 tons. Trajan's column in Rome contains some of the largest stones ever lifted in a Roman building, and engineers are still uncertain exactly how it was achieved. A list of the longest, highest and deepest Roman structures can be found in the list of ancient architectural records. Roman building ingenuity extended over bridges, aqueducts, and covered amphitheatres. The sewerage and water supply works were remarkable, and some systems are still in operation today. The only aspect of Roman construction for which very little evidence survives is the form of timber roof structures, none of which seem to have survived intact. Possibly, triangulated roof trusses were built, this being the only conceivable way of constructing the immense spans achieved, the longest exceeding 30 meters. China is a cultural hearth area of Eastern Asia. Many Far East building methods and styles evolved from China. A famous example of Chinese construction is the Great Wall of China, built between the 7th and 2nd centuries BC. The Great Wall was built with rammed earth, stones, and wooden, later bricks and tiles with lime mortar. Wooden gates blocked passageways. The oldest archaeological examples of mortise and tenon-type woodworking joints were found in China, dating to about 5000 BC. The Yingzhou Fashi is the oldest complete technical manual on Chinese architecture. The Chinese followed the state rules for thousands of years, so many of the ancient, surviving buildings were built with the methods and materials still used in the 11th century. Chinese temples are typically wooden timber frames on an earth and stone base. The oldest wooden building is the Nanchen Temple, dating from 782 CE. However, Chinese temple builders regularly rebuild the wooden temples, so some parts of these ancient buildings are of different ages. Traditional Chinese timber frames do not use trusses but rely only on post and lintel construction, are an important architectural element of the dugong bracket sets. The Songyu Pagoda is the oldest brick pagoda, dating to 523 AD. It was built with yellow-fired bricks laid in clay mortar, with 12 sides and 15 levels of roofs. The Enji Bridge is the world's oldest open spandrel stone segmental arch bridge, built in 595–605 AD. The bridge is built with sandstone joined with dovetail iron joints. Middle Ages. The Middle Ages of Europe spanned from the 5th to 15th centuries AD, from the fall of the Western Roman Empire to the Renaissance, and is divided into pre-Romanesque and Romanesque periods. Fortifications, castles and cathedrals were the greatest construction projects. The Middle Ages began with the end of the Roman era, and many Roman building techniques were lost. But some Roman techniques, including the use of iron ring beams, appear to have been used in the Palatine Chapel at Aachen, c. 800 AD, where it is believed builders from the Langobard kingdom in northern Italy contributed to the work. A revival of stone buildings in the 9th century and the Romanesque style of architecture began in the late 11th century. Also notable are the stave churches in Scandinavia. Materials. Most buildings in northern Europe were constructed of timber until c. 1000 AD. In southern Europe, adobe remained predominant. Brick continued to be manufactured in Italy throughout the period 600–1000 AD, but elsewhere the craft of brick-making had largely disappeared, and, with it, the methods for burning tiles. Roofs were largely thatched. Houses were small and gathered around a large communal hall. Monasticism spread more sophisticated building techniques. The Cistercians may have been responsible for reintroducing brick-making to the area from the Netherlands, through Denmark and northern Germany to Poland, leading to Backstein Gothic. Brick remained the most popular prestige material in these areas throughout the period. Elsewhere, buildings were typically in timber where it could be afforded stone. Medieval stone walls were constructed using cut blocks on the outside of the walls and rubble infill with weak lime mortars. The poor hardening properties of these mortars were a continual problem, and the settlement of the rubble filling of Romanesque and Gothic walls and piers is still a major cause for concern. Design. There were no standard textbooks on building in the Middle Ages. Master craftsmen transferred the knowledge through apprenticeships and from father to son. Trade secrets were closely guarded, as they were the source of a craftsman's livelihood. Drawings only survived from the later period. Parchment was too expensive to be commonly used, and paper did not appear until the end of the period. Models were used for designing structures and could be built to large scales. Details were mostly designed at full size on tracing floors, some of which survive. Labor. In general, medieval buildings were built by paid workers. Unskilled work was done by laborers paid by the day. Skilled craftsmen served apprenticeships to learn their trade from the parents. It is not clear how many women were members of a guild holding a monopoly on a particular trade in a defined area. Towns were in general very small by modern standards and dominated by the dwellings of a small number of rich nobles or merchants, and by cathedrals and churches. Techniques. Romanesque buildings of the period 600–100 AD were entirely roofed in timber or had stone barrel vaults covered by timber roofs. The Gothic style of architecture, with its vaults, flying buttresses and pointed Gothic arches, developed in the 12th century, and in the centuries that followed ever more incredible feats of constructional daring were achieved in stone. Thin stone vaults and towering buildings were constructed using rules derived by trial and error. Failures were frequent, particularly in difficult areas such as crossing towers. The pile driver was invented around 1500. Achievements. The scale of fortifications and castle building in the Middle Ages was remarkable, but the outstanding buildings of the period were the Gothic cathedrals with thin masonry vaults and walls of glass. Outstanding examples are Beauvais Cathedral, Chartres Cathedral, King's College Chapel and Notre Dame, Paris.